Hello and welcome to project number 2 electromechanical robotic systems. My name is Rishabh Shah. In this project we are using an Ardiuno board to control the direction and speed of a car using three LEDs to indicate the direction in which it is going, a potentiometer to control the speed, a tilt switch to set the speed limit when the car is going on a slope, and a joystick to control the direction of the car, which is reflected on the LEDs. Now let's see how this project actually works. Right now my car is my potentiometer is at its least resistance. That is why my car is running at a speed of 100 and it is going straight where the green LED is on. Now I will use a joystick to change the direction of this of the car. So I turned it to the left, it went to the left, and now it can also go to the right. So this is how the direction of the car is controlled. The potentiometer helps me change the speed of the car, and it also changes the illumination of the LED accordingly. So right now if it's at speed 100, as I keep increasing the resistance, the LED becomes dimmer and dimmer, and it increases as I increase the speed. And this is also reflected on the serial monitor. So you can see as I reduce the resistance, my speed increases, and as I increase the resistance on the potentiometer, the speed decreases. So this is how it goes. Now I can also use this tilt switch to set the speed limit at the specific speed at which a car is going when the tilt actually happens. So right now my car is at 67 kilometers per hour. So if I tilt it right now and I go, now my car will not increase. uh, so if I tilt the switch and it's at say 84, so it will not increase the speed because it has set the speed to 84 even if I'm changing the potentiometer. So that is how this is working. So the tilt switch sets the speed limit, but it can go below it. So if I want to go below it, I can increase the resistance, and the car speed limit can speed can go below it, but it cannot go above 84. It's set to 84. So that is how this thing works. Now we will explain the circuit connections. First we have the potentiometer. So the potentiometer takes a 5-volt input. Then we have this white cable that goes to digital read pin number A0, and then one end of the resistor is grounded. So this is how the potentiometer is connected. Then we have the tilt switch, which takes input from digital pin 9, and then one end of it is grounded. Then we have these three LEDs that take inputs from digital pin 9, 10, 11, and which are connected to 220 ohm resistors, which are connected to these LEDs. Other than that, we have the joystick, which has one wire that goes to ground, one wire that goes to a 5-volt power input, and then we have the VRX that controls the X direction of the joystick. So that is that VRX goes to A1 on the analog reader. So that is how my entire circuit is connected. Now I will explain the code. So first, we have provided variables to all these pin numbers, and then and then in the void setup we use the pin mode function for the LEDs and the tilt pin, which is our output. Then we have the serial begin that provides the frequency. Then in the void loop, what I've done is we have the analog read function for the potentiometer pin, the joystick pin, and the tilt pin. I've created a boolean to show when it's low, um, and that's when like my requested speed works. That is, I've used a map function to go from low to high of the potentiometer, that my speed goes from 0 to 100. Then the string is used, that is if else. So if my reading is less than 400 for the joystick, then the left pin turns on. If it is more than 600, then the right pin turns on. And if it is anywhere between 400 to 600, other than that, it keeps going straight. Then I have the speed limit, which is set to 100 for tilt being active. Then I've used the map function to control the brightness of the LED. So as the speed goes from 0 to 100, it goes from 0 to 255 for the LED. And then we have the analog write function for the three LED pins, that is digital pin number 9, 10, 11. Then for the serial monitor output, I've used these serial.print in order to get this output on the serial monitor. And that is how the entire code works. I provided like a small delay of 0.08 seconds in between. So that is how the code works, and this is how the circuit is connected. Thank you.